All right. We are getting this thing going. Cool. I think we are connected. We're going to go through the live stream check. Cool. I think we are connected. We're going to go through the live stream. All right. We have audio. Very nice. Very nice. So, we have got confirmation that we are live streaming. Ladies and gentlemen, welcome back. It's been a while. Those of you who missed the live stream, not to worry. As always, the live stream's available. So if you, after we're done, we're kind of just chilling out today. There's been a few new things to pop up on AliExpress ever since the E3D Revo has been talked about. So I figured, you know what? Let's see what's going on up in China. See what's going on in China. You know, they're always up to something. You know, doing some crazy stuff with the parts. 3D Experiments. How's it going, my dude? Nice to see you. Welcome to the live stream. We just started. We're kind of waiting for everyone to pop on in, whoever's going to come in and, you know, join us. So if you have anything 3D printer related you want to talk about, drop a link about it in the chat, and I will check it out. Got some Zevia soda. Help me keep from getting too parched during the live stream. Oh, I figure, you know what? It's a Saturday. It's not too late in the day. It might be a good time for a live stream. Yeah, well, hey, you know what? If you got to go eventually, you got to go. I get it. Life is hectic, especially nowadays. But yeah, so we're just chilling right now. It'll be around like 5-10 minutes in. We'll start actually, you know, looking at some parts. Give people a chance to jump into the stream if they want to. I didn't really announce a live stream. I just thought, hey, you know what? I'm not doing anything right now anyway. Might as well give it a shot. So that's why we're here. Although, so the Revo stuff. The Revo is pretty freaking cool. I don't know if I'm super convinced that I would ever really need a Revo. I never really had a problem doing swapping nozzles on a standard block. But I can understand why people would want that type of system with a nozzle and heat break is all in one, because I've stripped them a fair bit of threads on heat blocks before, but once you move to a copper heat block, that really just isn't a problem anymore. But let's see. 3D Experiment says that I heard Mello has some CHT clone nozzles, but I can't find them. Wanted to try it. Also looking for a wear-resistant V6 nozzle. So the CHT nozzles, yeah, the one that 3D Solex patented and is licensed by Bondtech. Stefan over at CNC Kitchen did some interesting testing with those things. They look really cool. And in fact, I plan to buy one in the 1mm diameter because I have been doing some 3D printing that needs to be watertight. I'm getting into gardening this year because, whoo, buddy, have you seen them gas prices and food prices? Oh, lordy. I'm going to grow my own food for a bit and see if I can make my little home a little more sustainable. But yeah. The nozzle that we're gonna put it on the Hamera. We tried doing 1mm diameter printing with the Hamera with just a standard nozzle. And I had set the print to like 150 millimeters per second, which was really dumb. And we found that at that diameter, we could not break 30 millimeters per second without having serious issues with extrusion. So I'm like, uh-oh, we need a high flow system. I remember the CHT nozzle, and I'm like, you know what? It's only $20. It's a brass nozzle, but yeah. Also, speaking of the CHT nozzles, if you actually look at 3D Solex's 3D printer nozzles, they have the same thing as Bondtech, only it's ruby. So they do have wear-resistant versions. Now, I can't find any pictures of the inside of said nozzle. I don't think the whole thing on the inside is ruby, just the tip. But it does. 3D Solex does have wear-resistant versions. Now, because it's patented, I don't know if we're going to get any wear-resistant versions out of AliExpress. Now, 3D Experiments, you were saying that you heard Mello had some CHT clones. I'm curious. I'm really curious because when it comes to patented stuff, the stuff that gets actually enforced, remember we were talking in a few past live streams how the slice engineering mosquitoes just disappeared after the patent was fully granted, and you can't find them anymore. And things that are very derivative of it that infringe on the art of the patent, just gone. Even in China, which is you kind of imagine that, you know, on AliExpress they really don't care, but man, they're enforcing it. So I'm curious to see here, but I've also been kind of looking to see if there are some off-brand CHT nozzles, just because you never know. And I want to look that up while we're here on the live stream. Maybe we come across someone who's just a little bit unafraid about the patent. I'm curious. You know, I'm not saying, you know, you should. I'm not advising to break patent law or anything like that. I'm just saying it would be interesting to see a wear-resistant version. Although, as Stefan pointed out on CNC Kitchen, the reason probably there isn't one right now is because it is a bit of a tricky mess to manufacture the nozzles. So I don't know what kind of machinery you'd be able to use to make it, but just give it time. Someone's going to come up with something, I'm sure. But there is also, yet again, more stuff to talk about with nozzles, actually. The Diamondback nozzle has been something that caught my eye, as well as E3D's. I think they call it the Obsidian nozzle. Excuse me. Good heavens. All of that stuff we're going to be taking a look at today in the live stream. We are just about to hit 10 minutes. We got another minute and a half before we start really diving into all the stuff here, because there's so many different topics. This industry never stops moving. It never sleeps. It is going strong. And honestly, right now, if you have a 3D printer, load up on filament before things get crazy and supply chains get destroyed again. Load up on filament. Overture has a sale going on. Check them out. Hatchbox doesn't always have sales. When they do have sales, it's pretty good. You usually have to buy in bulk in packs of 10 kilogram, 10 kilograms. Yeah, usually to get any good deals out of them. But I love Hatchbox and I love Overture. Never had a problem with their filaments. But let's see. All right. We are getting to the 10-minute mark now, so it's about time to start looking at the craziness. Starting out, the Revos. Let's see what we can find for Revo stuff. Let's see. Let's just type in Revo hot end. What do we get? Okay, nothing specific. I have been seeing a bunch of the nozzles for Revo stuff. Ooh, okay, hold on. This one right here, the Volcano adapter. This is something Stefan made on his channel on CNC Kitchen, and immediately after he started talking about it, these started popping up. Oh, I'm trying to point. There we go. These things started popping up, and it's a great little concept. And I might get one myself. It's only like $2. I have to get myself a Volcano heat block, but that's like whatever. Just get a cheap one, right? These things are cool because it's literally as you would imagine it to be. So let's talk about that. It's got a hex head on top, and it basically just covers the gap between the nozzle and the rest of the block, so that way your heat break butts up against everything properly. So you don't have to buy Volcano specific nozzles anymore. You can just get I guess you call it an adapter, or I don't know what you want to call it exactly. But it allows you to just use your standard V6 nozzles on a Volcano setup without having to get a Volcano nozzle. And I think that's pretty freaking sweet, especially if you have a bunch of V6 nozzles lying around and you don't really feel like buying a bunch of extra stuff. The Volcano... 3D says the Volcano adapter's already in his cart. Dude, I know what you're saying, man. I gotta get me one of these too. Dude, Stefan comes up with the most amazing stuff. Dude is an absolute legend. I love CNC Kitchen. He's always on point. But yeah, dude, no, there's so many of them. In fact, there's so many of them. They're even selling the defective ones. Yeah, like look up here. This product has some defects but still can be used. So they were trying this out the moment they came out with it, and they're like, oh, we can make that. And they're just like, oh, well, we kind of screwed it up, but someone's going to buy it. So I'm just like, dang. Oh, yeah, I could see where they messed up right here. That hex is not centered at all. Mello also has a Volcano mosquito. Is that what you're trying to say? But anywho, these little adapters, great idea. I definitely want to try one out. Oh, here we go. Oh no, wait, those are regular Volcano nozzles. Hold on. I'm trying to look for the CHT nozzles, or not CHT. The Revo stuff, because the Revo uses ceramic heating cores, so we're already starting to see it on AliExpress. We got ceramic stuff, and the ceramic heating cores are interesting because they're variable. If I understand them correctly, they're variable power output, so they can get really freaking hot really fast and then just maintain a very steady temperature without relying on like a specific PID tune, which not entirely sure how it's all set up. I'm pretty sure you do need a special adapter board. It does not go directly to the power headers for the heating element on the motherboard of your 3D printer. But if you look at them already, it's not just the V6s. They got them running on your Micro Swiss clones as well. So if you really wanted to go this route, absolutely there. And in fact, the funny thing about it is, these ceramic heat cores, they make extended versions of these heat cores, so that you essentially have a Volcano compatible nozzle set up. And I'm pretty sure you could just slap one of these extended ceramic heat cores on a Micro Swiss component right here and make a Volcano hot end out of a Micro Swiss hot end. or at least the Volcano setup, everything below the heat break, which I find it kind of funny because typically when you see that, you think V6, not CR10, which that would actually be pretty cool. I Franken-Swissed the crap out of my current setup. Like, it's just its own strange amalgamation of whatever, you know. So I'm just like, maybe this was actually, that'd actually be kind of cool. But so it's got the thermistor and the heater all into this one compact little setup. But aha, here's what I was talking about. In order to use these things, you got to use this little adapter board or DC to DC booster module. Well, hold on. This is coming from a 12-volt power supply. I actually don't know why you would need a 12-volt. Why you would need this if you're using a 24-volt native system. Because let's look. We got power going in. Power V plus. Yeah, this is just like converting 12 volt to 24 volt, I'm pretty sure. So I don't think you need this if you're running a native 24 volt system. So maybe actually you don't need it at all. Oh, hey, look at that. Pre-ferrule crimped. Hallelujah. More companies need to start pre-ferrule crimping everything. I got ferrule crimps and everything on my printer is ferruled. I do not trust anything that is not ferruled. It is the only right way to do it, in my opinion. But I wonder. Let's take a look. Let's take a gander. Let's try looking up CHT nozzle. I wonder if we get anything. Cause we're not pulling up anything that looks like the what you call it. The CHT, where it's the core heating technology. Remember, that is still patented. 3D Solix patented it. Bondtech licensed it. So it's unlikely we're going to see anything. Let's see. Oh, we got someone else coming. Ken is this? Says happy printing. Well, thank you for joining us. Happy printing indeed. Printing has become so useful in this era of hard-to-find things. Now, one thing we were talking about, Revo stuff. Now, I've been seeing a lot of these, and I've been wondering about the funky kind of look to them. The actual Revo systems, they combined the heat break and the nozzle in one, and I'm not entirely sure how exactly this is supposed to line up with any of that. But it's got the same thing kind of going on. It's got a what is this? Is this a silicone sock over the ceramic core? Or no? This is kind of weird. I gotta figure out what's going on with this. Oh, maybe that's not even related. This might be something different. Riley says, any ideas how to unclog a hardened steel nozzle? Been printing carbon fiber nylon and it's been a pain. Ooh, there's a few ways you can go about unclogging that nozzle. In fact, I've got a video about it. One sec. A little parched. So, carbon fiber nylon, that is some high temp stuff. Now, if you want to unclog it, fire. Just get yourself a propane torch and something to grab the nozzle. Wear some special like kitchen gloves so that you don't burn yourself. Hey, it can't be a solid if it's a liquid. Basically, you just burn the crap out of that nozzle until everything inside it turns to ash. And then when that happens, load it up in your printer, get something in there and do a cold pull to remove the rest of the ash, and then try printing at the highest temperature that you can do with just some typical filament and see if that unclogs it. Failing that, if you don't have a propane torch, what you could use is a soldering iron. So take the nozzle in the heat block, keep the nozzle in the heat block, and just remove it from your system. Put it in like a vise, and then just put the instead of having a heater cartridge for your printer, just put the soldering iron where the heater cartridge would go, and bada bing, bada boom, you're heating everything up. And that soldering iron is usually going to get a lot hotter than your 3D printer will, and that'll help sort of loosen up the goo. And then you can start taking stuff like a little pick to the inside of the nozzle, because you don't have it connected to the rest of the hot end, and you can kind of scoop up the gunk if you have a really thin pick. Now, you're asking, is that not going to ruin the temper on the hardened nozzle? I can tell you from experience that it hasn't ever been a problem for me. I only use hardened steel nozzles, and I have had clogs before. And my clogs have been with PET G. Unfortunately, PET G is a nightmare to get rid of. But any plastic turns to ash with enough fire, and from what I can tell, I haven't ever had a problem. They seem to work just fine when you just give it a whole bunch of fire. So, let's see. You've modified the firmware to print up to 300C using Gulf Coast Robotics hot end thermistor setup. Very nice. So, yeah, I would say just give it some fire. It's a hardened steel nozzle. It's probably like, if it's not A2, it's probably M2. So, especially if it's M2 hardened steel, then you really don't have to worry about it. M2 doesn't give a crap about you or your opinions. It's easy to burn that filament out of that stuff. The nozzle's not going to care. The only time it really matters is if you're still using brass. A2 might be the only one that might have a slight issue, but M2 definitely doesn't care. Riley says, I've never actually never had a clog with PET G with the stock or the all metal hot end. So PET G, the thing about PET G is I love this stuff. Like, it is an amazing filament. It can be flexible, it can be hard, it can be chemical resistant. It's got like the wildest properties. But I'll tell you what, when it does clog, holy heck, it's a nightmare to clean. Because there's literally like no chemical that dissolves it. I have actual mech, like methyl ethyl ketone, like the pure stuff that's supposed to dissolve PET G, and it doesn't. I did a video on it a while back. It's still in the mason jar 2 months later, and nothing has happened to the PET G in mech. It's astonishing. Let's see. You're saying you think it's an A2 from Gulf Coast Robotics. So, A2, I really don't think anything bad's going to happen when using fire on the A2. And the thing is, you don't even really have to put a whole lot of fire on it. What I do is I take the nozzle and I make sure that the open end of the nozzle is on a 45-degree slant. So that way, when you're dousing it with the fire from the torch, it has a chance to kind of slide out. It's been a while since I used an A2. I usually use M2 at this point, but hardened steel, I don't think it's going to be a problem. I've never had much issue with using fire. Fire seems to kind of be like the only thing that for sure gets the things unclogged. I've tried, like I said, I've tried experimenting with chemicals, but honestly, to no avail. It does remind me, I got a video I'm going to be doing soon about seeing the effects directly of acetone on ABS. We're just going to drop some ABS sticks in the mason jar with acetone and see what happens. All right, so moving on. Let's see. So we were looking originally for CHT nozzle clones, and didn't really get anywhere. Although, since we're on nozzles, this is a nozzle that I have been very interested in. Tungsten carbide You don't see too many tungsten carbide nozzles out there, but there's a great reason to have tungsten carbide if you're doing like a crap ton of abrasive printing. Tungsten carbide it's the same stuff you'll find that's used on like cutting saws that cut through thick metal. And this stuff is just, I mean, like, it's pretty hard to destroy tungsten carbide, especially with plastic. Riley says, thanks for the help, Andrew. Back to work. Stay blessed, guys. Well, thank you for dropping on by, Riley. It's always nice to have questions and see if I can help out. So, tungsten carbide. So, the thing is, all right, so we're going to talk for a second about wear-resistant nozzles, because there's a lot of options out there. If you're starting to get into wear resistance, the first ones you're going to run into are going to be like A2 hardened steel, which is like, okay, that's the entry level. Then you're going to find M2 hardened steel, which is like, okay, now you're getting into some more serious wear resistance. Then you're going to find things like ruby, because ruby is relatively slick, actually, but there's a kind of an issue with the inlay of ruby inside of the brass nozzles that they still are like press fit into. And I've heard rumors that the ruby tends to pop out of its place on the nozzle because of the expansion rates being different from the brass that they're encased in versus the actual ruby tip. We can actually, why don't we look up a ruby nozzle? Ruby nozzle. Let's take a look. Okay. We're just going to pick one at random here and talk about it. So these ruby tip nozzles, they're still encased in brass. And the problem with it is it's the whole innards is not really ruby. It's a lot of brass with a ruby tip. Now the ruby tip is where most of the abrasion is going to be, but it's still going to wear out the inside of the nozzle and make the inner portion of the nozzle as it goes down a little bit wider. And eventually, what people end up talking about is this little ruby tip ends up popping out of place because the brass expands and the ruby doesn't. So you end up having a problem. So I'm not really sure how much we can rely on ruby tip nozzles. That's where we start getting into just the idea of let's just keep the nozzle made out of one material. And that's where you get tungsten carbide. Tungsten carbide has been around for a while. It gets used all the time in vehicle repair, construction, just tools in general. You want something that's not going to get destroyed immediately. Tungsten carbide is a pretty hard metal. It stays pretty solid for a long time. Riley says, oh, have you seen the diamond nozzles from Diamondback? That's probably the king of all nozzles. Yes, in fact, we were going to talk about that. We were talking about it earlier, and while we're on the topic, let's go ahead and look at the Diamondback nozzles. Diamondback nozzle. Let's look and see. All right. Diamondback. So these things are, in fact, actual diamond. It's polycrystalline diamond. Now, I actually had a bit of a concern with the use of diamond in this type of application for one reason in particular. And give me a sec. Let me moisten myself. I'm gonna talk about it because it's an issue I've heard or had in the 3D print or in the computer industry. All right. So, my main concern with diamond is that in order to make diamonds, traditionally, you have carbon and you add heat and compression, and that makes a diamond. Now what happens is if you have a diamond and you just heat it up, guess what happens? It turns back into carbon. So I'm like, huh. When I was in the computer industry, a lot of people don't know, but I at one point was an A plus, Network plus, Security plus certified technician and a certified microcomputer servicing technician. And one of the things that comes up a lot with things like thermal compound or even just ideas, there's actually a patent out there for a heatsink made of diamond, because diamond is the best conductor of heat that there is. It's very good at it. Like copper, no, not even close. Silver, not even close. Diamond, all the way up there in terms of conductivity and heat. So someone had patented a heatsink for like CPUs made out of diamond. The number one issue was, well, no one made it because if you did, eventually the heat from the CPU would just turn the heatsink back to carbon. And then what are you going to do with it? So when I saw this nozzle, I thought, for conducting heat and heating up the filament, yeah, it's going to work pretty good. The wear resistance, absolutely going to be amazing. But what are you going to do when the heat, which is way hotter on a 3D printer than it'll ever get in a computer, like on a CPU, what's going to happen when the heat starts to slowly form the diamond back into just carbon? Now, I actually asked Diamondback, or the people who make the Diamondback nozzles, this. I didn't get a response directly from them. However, someone else did comment and clarify and said that this is not exactly the same as a typical diamond. The polycrystalline diamonds that they use to make these nozzles are different, and despite having similar properties, they shouldn't suffer from that particular issue. So I wish I had better details, and I actually do want to get in contact with the guys who make these nozzles and see for sure if they've done any testing in regards to this, because that's really my only concern with them, is what happens when diamond starts to revert back to carbon. Diamond has some very weird properties. Like, diamond is very flammable, apparently, and it's also, it dissolves in water. Like, I don't know if people realize, you get the right type of diamond and it can just go, oh, we're gone, for a lot of weird reasons. So, in theory, great idea. In practice, also probably still a pretty decent nozzle, but long term has yet to be seen exactly. But this isn't like people have been saying diamond for a long time would be the perfect solution for 3D printing, and finally someone's done it. So I'm very curious to try it out at some point. I don't know what kind of filament you would even begin to need this with. Because, like, tungsten carbide, like we were looking before, that should be able to handle just about anything. But, I mean, this really is kind of like you're looking at holy grail territory. And I've actually seen the inlay of this diamond on the nozzle. It's not just this portion of the tip right here. It actually goes all the way to the edge of the tapered on the inside. So supposedly it shouldn't wear out, despite the fact that it's basically just in a brass encasing. Which, that's the one thing that irks me about these types of systems, right? You got the diamond, one of the hardest materials that you could possibly ask for. One of the best thermally conductive materials. It's there for abrasion resistance. And then you choose to put it in brass? Couldn't you have, used something a little better? Because my worry is, what if you're putting this in a heat block, right? And you just kind of slightly over torque it, and then you shear the nozzle from the threads in half. That's happened to me with brass nozzles when I put them in a copper block. I've actually had to use screw extractors to remove nozzles out of copper heat blocks. And my thing is, if you're going to spend $100 on a nozzle, couldn't you guys have at least chosen something a little better than brass? How much more would it have been to use something a little stronger? Was there some sort of design consideration where brass absolutely had to be necessary? I don't know. It just feels like that's going to be the weak point. Like, God forbid you shear the nozzle when you're torquing it to spec. That's just going to suck. Just no ifs, ands, or buts about it. But while we're talking about nozzles, because there's so much news in nozzles as of late, let's look up, what is it? The Obsidian nozzle. Obsidian nozzle from E3D. Do they have anything? I don't think they have the Obsidian nozzles yet. Because you see, Diamond is gonna come to nozzles in many forms, and if you watched the release of the Revo and the Revo systems that E3 had a few months back, they also talked about a special type of coated nozzle where it's going to be like this diamond coating in multiple funky layers, and E3D is claiming that the nozzle will never wear out. And they're not just all talk. They straight up told someone, if you ever wear out this nozzle, not only will we pay for your filament and give you a replacement and yada yada, but if you ever wear it out, we will cover the cost and reimburse you. We just want to know how you did it, because they could not find a way to wear out the nozzles. So they claimed. And I'm trying to find out what it is, what it's called exactly. E3D Diamond Nozzle. Huh. I'm not finding anything on it, which is kind of weird. They were talking about it. I don't know where it's gone or when it's going to come back, or when it's going to come on the market. But Diamond is making its way in a big way to the 3D printing industry. And make no mistake, Diamond is going to be the gold standard, because nothing conducts heat better than Diamond. Nothing is going to be more wear resistant than Diamond. And I'm just waiting until eventually someone comes out with a full Diamond nozzle, and then it's just like, okay, never buy a nozzle ever again. So we're going to have things like that, man. It's getting wild. It's going to be interesting. But moving from there, let's see. You know, the Revo hot end, I can't remember if there was something about the Revo that I'm pretty sure was patented, but was going to be readily licensable. I can't remember what exactly. I have to look into that one again. Let's see. Riley says, any thoughts on the Vorons, and do you have any or plan to build one? So the Vorons are very interesting. Vorons are built to be stupid fast in terms of their printing capabilities. Ooh, excuse me, soda. I don't have any plans to build a Voron, because I actually have plans to build a completely custom printer from scratch. Using, instead of belts, I want to use ball screws on all the axes, because ball screws are really cool. And in fact, let me see if I can pull it up here. I love the Voron stuff. It's super awesome that we got like a totally open source 3D printer that's just like you can buy it and build it however you want. I think that's great. There's something about belts that I just don't like for using it for every axis. Hold on, let me look up ball screw 3D printer. I swear there is a video out there that it's an industrial machine that just uses all ball screws. There's just like this R&D department that just had nothing but money to spend, and they used all ball screws. Okay, let's see. This might not be quite it. It's going to be something similar. So first off, credit. This is on. Just want to credit maker Mike's Hobby Corner. This is his video. Full credit to this guy. Hope you're okay, dude, with just some fair use stuff. I just want to highlight your stuff. This is a ball screw printer. It's using ball screws on every axis. Ball screws, as long as you get a good set, just get some like high-wind, high-grade ball screws, and you've got something that has almost zero backlash, has some super smooth movements, and there's a reason. There's a reason why ball screws are used for some of the most incredibly accurate linear motions in machinery that requires it. But ball screws are sweet. The thing about it is, ball screws are expensive. If you talk about a lead screw, let's just say a 300 millimeter lead screw for the Z-axis on an Ender 3. It's about $10 for that lead screw. If you want an accurate ball screw, and I'm not talking the cheapo depot ones that have a bit of slop that are cold rolled, I'm talking like proper CNC machine ball screws from High Wind that are high grade stuff, you're looking at about $1,000 for a single ball screw and ball screw shaft. That's a lot of dough. That is a lot of dough. I'm probably not going to go outright with that first. But here's the thing. The idea is to start out with cheap ball screws and just get everything built properly. Every axis is going to have a ball screw. And every axis is also going to be moving on linear rails. So the idea is linear rails for the motion and then ball screws for the movement. I want to build an industrial kind of printer that just does not give a crap. That just says, you know what? We're never going to need to be adjusted ever again. It's going to be precision. And in order to do that, I'm going to need to get myself a CNC router so that I can start designing and cutting some aluminum pieces to fit on some extrusions. And I'm thinking, maybe I turned an Ender 3 into a machine that uses nothing but ball screws. Maybe an Ender 5. Something like that. Not sure yet, but I have to decide on what CNC machine I want to get, because I want to make sure it cuts aluminum properly. I've got some ideas, though. And I think for all the Voron's goodness using belts, Vorons are very affordable in the sense that, yeah, they're using belts, and especially if you use like Gates power grip belts, there shouldn't really be much backlash, if any. And yes, belts do have backlash if you're not using like fiberglass reinforced ones. But a good ball screw system would be pretty awesome, man. I think the belt stuff is neat. But I've seen the industrial printers, and I want to see if we can kind of make like a prosumer printer. Like, the Ender stuff is, you know, entry grade. If you guys have seen my Ender 3 Pro, it's about like $1,100 worth of upgrades in that printer. It's a rock solid printer, but it's still not enough, you know? It's still not quite what I want it to be. So, plans in the works. It's just going to cost a lot of money, and it's going to take a lot of time to design, but eventually I'm going to do it. That's my hope. So, shoot, where were we? Man, I got off on a tangent there. So going back to the comments. Riley says, you could probably do that with very readily with the Trident design, which uses lead screws and modify it. Precision ground goodness. I want to build a Voron Trident 300 by 250 with an actively heated enclosure so I can print polycarbonate effectively. Without a heated enclosure, layer adhesion is a big issue with polycarbonate. Yes, it is. Polycarbonate. Holy sweet Jesus. That stuff has been around for a while. Everything from the headlights in your car to, bulbs for your ceiling fan or whatnot is usually polycarbonate. It's good stuff. It wasn't really ever designed for the 3D printing industry. It was really more the way ABS was as well, where it was for injection molding. But I don't doubt that there's probably going to be some polycarbonate blends designed for 3D printing. I mean, you look at ABS, they tweak the formula of the three things, the A, the B, and the S. Forget what each letter stands for exactly, but they tweaked it quite a bit. And in fact, Overture ABS is fantastic, amazing stuff for 3D printing. I've got some stuff that's like 10 years old and it definitely wasn't made for 3D printing, and it just sucks. That being said, polycarbonate or ABS, now we have ASA, which is basically like ABS for 3D printers in particular. I don't doubt that anything is going to be a 3D printer made, like even PEEK, P-E-E-K. Now they have PEK, P-E-A-K. No, is it P-E-K? P-E-K. Anywho, they have a special PEEK for 3D printers now to make it more easy to print. So every plastic is getting modified for 3D printers because why not? 3D printers are going to be the way of the future. It's going to be a household thing everyone has at some point, just because it's more economical than having to wait a few days for something to be shipped if you can just make it on your own. I really believe 3D printers will be as common as regular paper printers at some point, especially at the price point they're at. They're just getting better and better at the price point. But heated enclosures, funny you should bring that up. The patent on heated enclosures expired like I think a year ago at this point. So now we're going to be seeing a lot more heated enclosures. In fact, Creality, as soon as the patent expired, has a 3D printer with a built-in heated enclosure. So like they're like on the ball. As soon as the patent expires, they're on it. Riley says 3DX Tech makes a PC Plus that's supposedly very easily printable. They say an enclosure isn't even required, but will help. Kind of like how ABS Plus is to ABS. So if that's the case, you might be able to just get away with a passive enclosure. I use passive enclosures from Creality on my Ender 3s all the time whenever I'm printing ABS, and really, the temperature inside the enclosure stays about 80% of whatever the bed temperature is. It just allows the radiant heat from the bed to just heat up the enclosure, and because it's got like very reflective sides, it just reflects the heat back on everything. So if that's the case, maybe you don't even need an actively heated enclosure. You could just get away with a cheap one that just, traps the heat. The one thing with heated enclosures that I worry about is once you start getting into higher temperature stuff like that, then you have to start worrying about the heat of the stepper motors. But you could get water cooling for your stepper motors. That's a thing. We actually talked about it on a previous live stream where we looked at a bunch of water-cooled stuff. It is pretty freaking sick, and I'm pretty sure, no, I know for a fact, Teaching Tech Teaching Tech did a video where he had a water-cooled stepper driver set up because he was, in fact, printing in PEEK. And, man, PEEK is expensive. Good Lord. Have you guys ever looked at the price of PEEK? It's like $100 for 1/10 of a kilogram. Oh, could you imagine having to print Spaghettify like halfway through with that stuff? That would be heartbreaking. Absolutely heartbreaking. So hold on, let's look at E3D Revo. There's more stuff going on. Let's check it out. Let's bring it over here to the main page. The Revos, the newest and goodest of the stuff we got going on here. For y'all that have not been initiated, and for y'all who hate changing nozzles the old-fashioned way, we got this. Now, the Revos are basically, well, they're plug-and-play replacements, but the nozzle and the heat break are connected. They are one and the same in this setup. So there's no gap between the two, so there shouldn't ever be a possibility of a clog happening because you didn't torque the nozzle onto the heat break properly. And it's pre-tensioned. It's got like a tensioning system so that once you reach the right tension, you're good. And that's where these ceramic cores are coming into play. The old way of doing things, you had a heat block, a thermistor, a heater, or you got the ceramic heat core and a thermistor. Now, I think in terms of flexibility, the heat block, the old heat block style, still has more options to change it to make it however you want. I still prefer this. But I can understand the appeal of this to a lot of newcomers, just specifically because it's really hard to mess up. I've definitely had my fair share of issues with this setup when I first started 3D printing that kept me up at night. But I think I'm better off for it, sticking with it, but I can understand the frustration. Raleigh says Moons has high temp rated stepper motors that don't require water cooling, which would be the route I'd go. Ooh. High temp stepper motors, that's interesting. That's actually the first time I'm hearing of them. I mean, stepper motors are usually good up to like around 100 degrees Celsius. I think it's just really at a certain point you start losing steps due to the heat. Because you know how heat affects magnets? I forget what the actual scientific principle of it is, but if you got like a magnetic bed, like you got PEI on spring steel and that sits on a magnet, like on a magnet for your bed, the hotter the temperature gets, the more magnetism you lose, which is why typically when you use a heated bed for something high temp like ABS, you kind of have to use clips to hold the bed on, otherwise the magnet gets too weak and it just doesn't hold anymore. That is definitely a thing that happens, and I wonder if that's what's affecting the stepper motors, and why they lose steps at high temp. Maybe that's the only reason. Just a thought. It's probably something we should look into at some point. Scott says servo. Servo. What about a servo? Servos can compensate for lost steps because of encoders. Oh, you're talking about using servo motors. Yeah, I've actually seen people use servo motors in Voron builds for the speedboat races when people were were doing speed runs of benchies, because the servos are just way, way more torque that you can apply to them. Pretty wild stuff, actually. Now, that being said, if you are worried about losing steps, you could get a closed loop encoded stepper, which you have to have a specific board and program each stepper to do it, but it's absolutely a thing you could do. Servo motor instead of steppers. Yeah, I mean, it's definitely a thing. You could use servos. There's a few options. I mean, the two would be the servo motor or the closed loop stepper. Um, One of the two, or the third option would be water cooling the stepper driver, or the stepper motors. Which there's ways to get around the issue. It's just a matter of what's your flavor and how do you want to go about it. You know. But getting back to the Revo stuff, so they're releasing Revos for everything. CR10 mounted, V6 mounted. They have rigid mounts for your Voron stuff. They got everything going on up in here. And the Revo is, I could be wrong, but I think the Revo is a little lighter too. But if you look right here, they've got the spring that basically provides the tension on the threads so that the nozzle heat break combo doesn't unscrew itself as you're printing. So good idea there, and you could even use them on the Hemera. The only thing with the Hemera is with the Hemera we're using on the Ender 5 Plus is we're gonna use a CHT nozzle, and we're gonna see just how fast we can print 1mm prints with a CHT nozzle. I've seen the flow test from Stefan, but I want to actually put it to the test because I'm making a bunch of flower pots because I'm growing a bunch of food this year, and there's a bunch of fun designs, and they all need to be watertight, so thick layers, wide, the width and all that really, really helps everything stay watertight. But, oh, hey, yeah, this is what I was talking about. So, licensing. Yeah, so, okay. The Revo stuff is partially patented, but they're readily licensing the technology, so it seems. So, there's actually something to be said about patenting a 3D printed part. There's two ways to go about it. The way I see it, you can go the way that Slice Engineering did, and they do like, hey, we came up with this thing, we want to make money on it, we're patenting it. If you want to license it, you got to go through us, but most likely we're going to do our own thing. And the 3D printing community basically just had a collective shat and said, nope, not going to do that. Or you could do what E3D is doing and say, hey, we came up with this great technology, but to make sure no one else tries to design something like this and do what Slice did, we're going to patent it so that we can control it and then know that no one else can tell anyone what to do with this technology, and then we're just going to readily license it to anyone who wants it so that we can ensure that it stays as free and open as possible without some company coming in and claiming it as theirs and then causing a roadblock. So there's ways you can use patents to ensure that a design stays openly available to modify and design. It all depends on how you decide to use the patent. They're not inherently bad. So if you're going to patent something and then say we're doing it so that we can license it out to anyone who wants, that's a good thing. Because if a third-party company came in and said, hey, we're going to patent it first because you didn't do it, and then we're just going to make you license your own product that you designed, then that's some shady patent trolling right there, I tell you what. But, there's patents are wild, man. But there's good guy patents and bad guy patents. I think E3D is the good guy patent for sure. That being said, we do got to say one thing. The guy who was like the lifeblood of E3D, he recently passed away shortly after he got to debut the Revo system. So, spread some love for the guy. That really, really was just all about the community. Was, I think, Joel, 3D printing nerd, got to meet him shortly before he passed away. At the conference where they talked about the Revo stuff. He's a good guy. doing the Lord's work, so to speak. Couldn't find another way to put it, but you know, some people, they have great ideas, man. They really do, and they put it out to the world and let it blossom, and I absolutely love that. You know, but not to bring any downers into this. I just want to say, you know, since we're talking about E3D, gotta remember the people that make this industry as amazing as it is. So E3D, you know, the nozzles. I want to talk about the nozzles. Revo nozzles, View Classic, Cyclops View. I don't know why I can't find anything on their Obsidian nozzles, because I'm like, I know that's a thing. It's like a diamond coated layer system on it. I don't know why I'm not finding it. But let's go back to AliExpress for a hot minute, eh? We got, oh man, we're getting sidetracked and all that, but you know, while we're talking about Revo stuff, I mean, we're just getting some, like, you know what? Here's a V6, and we're just gonna put the ceramic heating core on it and let it do its thing. So we're gonna be seeing ceramic heating cores becoming super popular, as that is the way that a lot of people are predicting the industry is a moving. But I feel like there was some other stuff I was going to talk about. I keep getting sidetracked, and then I keep forgetting what it is I was going to go on about. There was going to be the Revo stuff. Oh man, why am I not? I am brain farting super hard. You know what? While I'm brain farting, let me give a chance to shill my own product and shamelessly self promote. So, y'all, about a month or two ago, I put the compression fittings that I use on all my hot ends on Amazon, and they sold out. They sold out in less than a month. They did really good. Those of you who bought it, freaking awesome. And you know what? It did so well that I am getting more. They're almost, to me, I have to get them and modify them all so that they work for 3D printers. But guys, the kit is going to be expanded. The kit is going to go from including one hot end compression fitting and one extruder compression fitting to having one hot end compression fitting and two extruder compression fittings. So that way, whether your extruder uses an M10x1 or 1/8 inch NPT thread, you will have a fitting for just about every combination of hot end and extruder that you could possibly find if they use threads. Obviously, if your system is using a Bowden collet, that's a little different. There's no threads on those, so you couldn't use it on that. But anything else that uses those threads, and those are the most common threads, that will be compatible with the kit that I am selling on Amazon. And you know what? While I'm being a shill for myself for a minute, I know, shameless plug and self-promotion. What can I say? While we're here, this is the thing, the compression fittings that I sell. I know. You got a compression fitting for the hot end, for the extruder, but we're going to be expanding it when the new kits arrive. We got a few of them sold. We sold 25 of them. We got 50 coming in right now. They'll be back in stock in just a few short weeks. All right. Shameless self-promotion over. Back to the parts on AliExpress. All right. So, does anyone else got anything on their mind for 3D printing today? Because I am open to looking at pretty much whatever y'all are looking at or want to talk about. Das Auto. Das Auto. Random AliExpress part browsing is fun. You know, I just want to say, great name. I got a friend, and he's got a Volkswagen diesel Jetta, and that thing just like has all the exhaust problems. So we call it Das Auto, just because I'm like, it's just his name. We call, but yeah, you know, 3D printing. This is one that I keep seeing popping up. This bizarre thing. 3-in-1 heating block. Okay, that's cool. Why don't you show me the thing? All right, well, here we go. Like what the heck is going on here? What is this? Why do we have 3 heaters? Why do we have 3 heaters going into this one thing? Like what is this? They really just it's just the most bizarre thing. uh Hi Amanda. One of my friends is in the chat. So, anywho, going through, I can't think of anything else that I wanted to talk about today because there was just so much stuff going on with the Revo situation that I wanted to get in on the conversation. And I'm not seeing a whole lot of stuff going on right now, but quick little live stream. I know Creality's been coming out with some new stuff as of late, but nothing particularly notable. They got their direct drive stuff on some of their newer Ender style printers. That being said, it's nothing particularly amazing. You know, it's another Ender with a really cheap direct drive. You know, it's like ooh whatever. But yeah, so all right, so not really too much going on after all that. So, anywho, I wanted to talk about some fun stuff that I found on the internet. We talked about some fun stuff that we found on the internet, and at some point, I am hopefully going to be getting some of said fun stuff, particularly the CHT nozzles from Bondtech. We're going to try and get one in 1mm, and we're going to do a live stream of that when I get it to see just how much plastic we can spit out of a nozzle and see how quickly we can make some stuff with just some... Oh, in fact, we were going to be using ABS for this, so fun stuff. We're not even going to use an enclosure. Yeah. Believe it or not, like we've had some really good success with ABS without needing an enclosure like at all, which is shocking. It really depends on how thick your layers are and how interconnected everything is. If it's like 100% infill, that stuff's going to warp. But if you are only using like 10% infill, it might not warp, which is pretty shocking. Overture makes really good ABS. I mean, that's just the short and sweet. Overture is really good for that. So, anywho, thanks for joining, guys. I don't know how long we've been going at this point. Oh, never mind. Oh, we've been going for 1 hour and 8 minutes. Holy crap. A little bit longer. Time really got past me here. That being said, we're going to wrap it up. Because, well, I mean, unless y'all got something you want to look at real quick, I'll give y'all a chance to type something in. And if you find something interesting, we can go ahead and talk about it. Scott says, love browsing Ali for stuff. You could end up with tons of stuff before you know it. Oh, yeah, there, bud. AliExpress has got a lot of funky stuff. Like the people that make stuff on AliExpress. They're just like, I don't know, let's try it. Someone will buy it. And certain enough, someone does. Cyclord87 says, would love for you to check out Shep's extra fast profile. So, Shep from Filament Friday. I haven't watched him in a while. His profiles are typically tuned for stock printers, and we do have one Ender 3 that is relatively stock. One of my friends got his first 3D printer, and I'm teaching him how to use it. The only thing we've really upgraded on it at the moment is we added a BL Touch, because we just had one laying around, so I figured why not. Actually, I should tell you guys a fun story with that, but also then we gave it a BMG extruder, because the stock extruder is absolute trash. Fun story, there's two kinds of BL Touches. One has a completely different wiring setup than the other, and we plugged it up, and it was the wrong wiring setup, and we kind of set the motherboard on fire. But here's the wild thing. I smelt the fire immediately. We shut the printer off. We pulled the BL Touch connections out of it. We turned it back on, and the printer works just fine. We're like, okay, well, let's try looking at the wiring diagram. And sure enough, we had to pop the pins out of the connections and reconnect them in the right orientation. And then like, okay, it's not on fire, and the BL Touch is doing stuff. And then it wasn't detecting the probe, and I'm like, hold on, let me check something. Sure enough, the probe wires that go for the end stop connection into the motherboard were also switched around from the factory. That needed to be switched. And then all of a sudden, we got it to work, and we're like, so we set the motherboard on fire. We could have destroyed the BL Touch by like sending the wrong power to the wrong part of it. And we had to change all the wiring, and despite all of that, it still works. We don't see a problem. It prints just fine. So, like, I don't know. Just pray it doesn't catch on fire. Ooh. Oh, Das Auto says, I hear he uses an Ultimaker profile for the basis, but I haven't watched the video yet. Can we just take a moment to wonder, you know, who's buying an Ultimaker printer? I don't know anyone who has one. They're really expensive, and I don't know why. Like, you could do so much better for the price. Now, Cura, I love Cura. That is the best software for slicing, in my opinion. But, you know, to each their own. Pure profile optimization reduced my print speed from 6 hours to 3 hours. Ooh, very nice. I have been optimizing my own profile for my custom printer setup for a while now. It really depends on what I'm printing. If a lot of the things that I print have very sharp 90-degree angle corners, and I really need like dimensional accuracy on a lot of my prints, so I typically don't print very fast because of that. Usually 50 millimeters per second is what I stay around. But for things that aren't as critical, like things in VOS mode, oh, that I just let that rip. That'll go, you know, as fast as I want it to. We got the Ender 5 printing at like 300 millimeters per second. Just doing a VOS mode print, and that thing was just friggin' flying. It's nowhere near like a Voron doing 1,000 millimeters per second, but I don't have the kind of flow to do that. But I will say this, even at 300 millimeters per second in VOS mode, it's so fast that the cooling fan could not cool the plastic down fast enough before the next layer started to get on top of the old one. And that ultimately caused a few problems in that VOS mode, but that was just for fun. There's a video of it on my YouTube channel where we're just like pushing the printer for no good reason. I'm just like, screw it, acceleration up, jerk up, G code 300%. Let's just go. Let's rip it. And it did shockingly well, honestly. But one thing I will say about the Ender 5, holy sweet mother of mercy, that touchscreen interface is garbage. I thought touchscreens would be awesome, and it turns out they're not. They're just bad. I like the encoder dial. It's faster, surprisingly. There's more options. I don't know what Creality was thinking with that software that they put on the Ender 5. It's just bad. Cyclord said, I'm looking to buy an Ender 5 Plus after watching your videos. I love all your videos. Well, thank you. I appreciate you watching. The Ender 5 Plus, let's be clear. It's actually a really good design. As far as frames go, I'm genuinely impressed with it. It has the potential to be a very, very good printer, far beyond anything that my Ender 3s would be. The problem with Ender 5s are the motherboard and the touchscreen. Replace that. Get like, you can use a standard Ender 3 encoder dial and screen. If you load up just any other version of Marlin on it, and you will be so much happier with that. You can get linear rails for your Ender 5, and it's probably easier to install in an Ender 5 than it ever will be for an Ender 3. I mean, the Ender 5, the Ender 5 Plus in particular, its motion system is very well designed. I actually really like it. The only thing I don't like is the bar right in front that blocks your view of the nozzle, so you can't see what's happening on the first layer. So if you need to adjust something, you just can't because you can't see. There are relocation brackets you can get. Probably going to do that at some point because I kind of want to see the first layer go down so I can make sure my baby stepping is perfect. But other than that, Ender 5, pretty sweet machine, honestly. It's got a lot of potential. Few things here and there I would change, but overall, I would say if you're getting a printer for the first time, don't bother with the Ender 3. An Ender 5 is probably going to serve you better in the long run, especially an Ender 5 Plus. It's going to serve you better in the long run than an Ender 3 will, in my opinion. There is a price difference, obviously, and the Ender 3 does have a broader support community in terms of aftermarket stuff, but the Ender 5 is still pretty solid. I haven't messed with any of the other Enders, but I mean, never really felt like I needed to. At this point, we're just chilling. We're just chilling and talking. Trying to find anything else that might be interesting. Any opinions on the S1 or S1 Pro? Is that, let me remember. That's the... Are we talking about the Creality with the direct drive on it? I'm pretty sure that's the one that's got Creality's direct drive on it. It's basically like an Ender 3 with a direct drive. Oh, don't worry about elongating the stream. I don't mind keeping the stream going just to chat, quite frankly. I'm fine with that. Like, I got literally nothing else to do right now. So I'm just like, oh, stream and chat. You know what? Hold on. Let's just look it up. Hold on. Creality S1. Yeah, I think I was on the right track. The Ender 3 S1. So this is... just trying to get some pictures up in this thing. Now, why would they make this web page where you can't make the picture bigger? Why would they do that to me? I guess we got a bigger picture here. So, okay. Few thoughts that I see right out the gate that I don't like. So, you see this ribbon cable right here? I get why they do that instead of having individual cables for each component. And it's to make it a little bit more sleek and to make it so that if you ever want to replace the hot end directly, you just unplug one cable. The issue I have with that is the moment you want to upgrade this printer or change anything out about it, now you have to completely reroute and create your own cable system that goes into the bottom down here where the motherboard is, and it's just kind of like, it seems unnecessary. I don't like these ribbon cable systems. Not to mention, these ribbon cables, the more you bend them, and it's going to get a lot of bending, I feel like you're going to eventually start to flex the cable enough that you're going to get a joint on it, and maybe it feels like something that would stress crack. Something like that. It's things like that I'm not really fond of. You can't really get a big cable to transfer a good amount of power. Not that you need a whole lot of power for these things, honestly. So not a fan of that. It looks like they're using their CR Touch on the hot end here, so their version of the BL Touch, which it does look to be better made. It's got a metal probe, so maybe that thing doesn't break as easily as the BL Touch stuff does. I haven't personally used it. I like easy ABLs from TH3D. Another thing I don't like, though, is these belt tensioners. They're made of plastic. And I get it. These are injection molded plastic, and they should hold up better, but I've already been seeing reports of like Ender 3 V2s, these little plastic things, just cracking and breaking. So I'm like, okay, what's the last thing that we've seen for the longest time that's also injection molded that breaks a lot on Enders, especially Ender 3s? The tensioner on the extruder wheel for the extruder. That thing always breaks. That's literally the one thing everyone says to upgrade immediately because it will break. That's injection molded too. This part is also injection molded. This part is also injection molded. And it's also maintaining tension. And we're seeing reports of these things breaking as it is because it's plastic. So it's one of those things where I'm just like, maybe you should be using a metal part there. I get why they do it. It's cheaper to make en masse, but, at what cost do you really want to do that, And then we've got your standard springs down here. Now, I still think tension mounts are way better than springs or solid mounts. I use my tension mounts on my printer that I have, and they have been friggin' flawless. For those who don't know, tension mounts, you're just basically using two wing nuts on the top and bottom of the y-axis gantry, and the tension of them being tight keeps them in place. And best solution I've ever come across. Let's see. Psych is asking, will printed ABS tensioners hold up for my Ender 3 Pro? Well, ABS stands to hold up better than PLA for sure. I've had components that were printed in PLA initially, and like my easy ABL mounts. And then the moment I put it in an enclosure, it started to get to the glass transition temperature and then slowly started to fall and melt, which wasn't good. Then I printed it out of ABS and had much better luck. Now, my guess is these things that are injection molded are also ABS, and usually injection molded parts are a bit stronger than 3D printed because they don't have the layers that can separate. I personally don't recommend using plastic on these things. You can get metal ones for like $10 for both the Y and X axis. And the metal ones, those are never gonna wear out, you know. So I would just pony up for the metal ones. In fact, you know what? While we're talking about it, let's just look up Ender 3 Pro belts tensioner, and we'll just look at these real quick. Like I'm trying to find ones that I think I like, but like this right here, you know, it's $8, and it's a metal tensioner. It's very similar to the one that I use, and because it's made of metal, you know, it's not gonna fatigue, and it shouldn't really ever wear out. And you can get these for your x-axis and your y-axis. And now, full disclosure, I've never bought from this particular company or this brand. If you've never bought one, there's plenty of them on Amazon that I've purchased. The one thing you want to keep in mind with Amazon, like I got one that's just like this. And sometimes these are cheap. Sometimes they don't bend the metal on these 90-degree angles properly, and you get something slightly askew, which is annoying. But so if you buy them on Amazon, you can always just say, hey, can I exchange it for one that's not bent? And then they send you another one, and then as long as it works, you're good. But this is very similar, if not the exact same thing as to what I got on my y-axis. These things are awesome. Do be aware, though, you can absolutely over-tension a belt, especially belts that are not fiberglass reinforced. So do be aware of that. Don't over-tension something. It's very possible to do. So if you want to buy like 3D printer belts, GT2 synchronous. The only belts that I buy are genuine Gates power grip belts, which are kind of hard to come across. These are not Gates. Here we go. These claim to be Gates. I don't know if they are. If the genuine Gates branded belts will have their logo and the type of belt written on the belt. So if you ever get a belt that you think is from Gates and you don't see Gates power grip on it, it's not Gates. You got to be really careful about counterfeits out there. There's a lot of companies that'll pretend to be Gates and say, oh, we're fiberglass reinforced, but then they're not actual Gates brand. Gates, by the way, freaking awesome belts. They make belts for like they make really high-end belts for like cars. For the timing belt on cars, and the fact that they make these for 3D printers is just like, hey, good stuff. I use Gates on my 3D printers. Freaking love those belts. Going strong. You can get worth-wise. You can also get like aluminum core belts. Maybe it's not aluminum. It's a metal core belt instead of fiberglass. Don't get the metal core. The metal core requires a very large diameter wheel to go over. Otherwise, you fatigue the metal and it'll just snap. So, fiberglass. Just fiberglass. It's good stuff. So, Sykes says, thanks again. Appreciate the insights. Great work as always. Happy to help. That's what we're here for. We're just talking and chatting, and anything I learn along the way, I am always happy to pass along. But yeah, this the fiberglass reinforcement right through here throughout the entire belt. That also helps prevent some backlash on the belt, because the non-fiberglass reinforced stuff, it tends to when you stop moving in one direction, it'll kind of You won't really see it, but it'll have a tiny bit of stretch as you start moving the other direction. Birdie. People using 2 GT belts with GT2 pulleys and idlers. Well, I mean, whatever works. Oh, well, 2 GT and GT2, I think there is a slight difference, but whatever I got has been working for a really long time now. Going back to the Ender 3 stuff. You know what? Since we're still just derping around here, well, I got a quick text. Just got to reply to a text. Alright. If you don't use Gates 2 GT pulley and their idlers, you are effectively wearing out the belt. They are not the same. Well, to be fair, yeah, you want to use the correct size teeth on the belts. Because, 2 GT, that specifies the pitch. I forget what exactly it specifies. But yeah, I mean, you definitely don't want to have some sort of pulley that is not designed for the teeth pitch of the belt. That wouldn't exactly be very good. But what was I gonna go on about then? I lost my train of thought again. Hold on. We were gonna logo. Oh, I know what I was gonna do. Ender 5 linear rail kits. Let's see what we got. Okay. Okay. Fun fact, this company, I don't know how to pronounce their name. Funsor, whatever. These guys know what the heck they're doing when it comes to linear rails on 3D printers. There was a video I wanted to put out, but I kind of held back because I felt like I was just ripping on a company too much. I have linear rails on every axis on my 3D printer, and the Y-axis I particularly got from Printer Mods because they were the only ones at the time that had a dual rail system for the Y-axis for the Ender 3, and the little mounts that connected to the linear rails were just off. And it caused horrible binding. And I had to shim the crap out of them to even make them work a little bit. And I got kind of annoyed because for my friend, we ordered some of the ones from Funsor that they make that does the same thing. And first time, without any shimming or any guiding, perfect fit, no binding, exactly the way it should be. And I'm thinking to myself, you know what? I thought, there's this thought that American manufacturing is supposed to be better. It's supposed to be higher quality, more accurate, this and that. And here I am getting a part from China from this company that no one's ever heard of, and it works out the gate. And yet this very well-known American manufacturer just couldn't get the one part they advertised to work right on genuine high-wind rails that they're supposed to be designed for. And I'm just like, it's getting harder and harder to justify some of the prices from some of these companies. It's a little annoying, but props to where props get deserved. This company, Funsor, man, they get it every time. Every one of their kits. Now let's be clear. They have no instructions. They're just like, here's the parts, yeet. And it's up to you to figure out how to cobble them together. But once you get it together, they are pretty freaking sweet. So some linear rail kits for the Ender 5 is definitely something I want to be doing at some point. Because linear rails, they're just so much better. Dude, if you want consistency, linear rails are just... They're so nice. So this would be, let's see, this is for, blah, 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 blah. It doesn't say what axes. This might just be, this might just be, I guess, the y-axis? Yeah, probably the y-axis. The x-axis would go across like this. So, a little different, but linear rails are so wonderful. The only thing that I want, okay, the only thing I really want for sure with the Ender 5 is I want an all metal build, or an all metal plate to connect to a linear rail to hold the Chimera. It is really hard to find anything for a Chimera, especially on an Ender 5. Like, E3D made a pretty decent hot end, but then they just decided, yeah, you know, here's the hot end. We're not going to have anything other than, like, call a few people up that like 3D printers and have them design it. Like, everything I've ever found for the Chimera needs, like, an insane amount of tweaks to get it to work at all. Which is just unfortunate, but it is the reality of Creality. Well, no, it's not even Creality, I'm sorry. It's the reality of E3D. Not everything E3D is an absolute banger out the gate. Because if I look up, okay, let's look up something like Chimera mounts Ender 5. Do we even get anything? I'm not showing anything. Did I just not spell it right? Let's just look up Chimera mounts. Okay. So we've got some stuff, but it's for the Ender 3. Like, the poor Ender 5 has just been kind of left to your own devices, which, this is why I need to get a CNC machine, because I can design a good mount. I just need to have something to mill it out. There was a guy who used to make them, but he doesn't make them anymore. And I'm like, dang, I should have got an Ender 5 sooner. Then I could have contacted the guy. There was the one guy, you could find his stuff on Reddit, and it was an all-metal linear rail mount for the Ender 5 to use your Chimera with, which is definitely what I want, and I would have paid good money for that too, because I do not like using plastic solutions for really anything on the frame. Let the printer print the plastic. I don't like the printer having its parts made of plastic. There's problems with that, you know. So if you guys ever come across one of these, like an Ender 5 linear rail mount for a Chimera, y'all let me know, because I'm gonna buy one of those real quick. I'm gonna snatch one up as soon as I find one, man. But yeah, you know, that's pretty much all there is to talk about for right now. You know, unless there's any other 3D printer news that I totally forgot. If you guys have anything, you know, you can always toss it in chat and we can look it up real quick. Otherwise we're just kind of just chilling, and there's not much of anything to do. I'm probably going to be ending the stream in the next few minutes, unless there's like some sort of thing to go off on another tangent about. Side note, well, I guess you can't see it with the camera because I've got, oh, wait, hold on. Zevia soda. This stuff's amazing. I love this soda. But yeah. Just some upgrades. So anywho, check out the vids. You know, if you're subscribed to the channel, hopefully we'll have a CHT nozzle for the Chimera soon. We're going to be doing some testing and see if we can't get that thing to spit some plastic. So until then, guys, I will catch you later. You guys can see me and my friends in some new upcoming videos. Little side note, I actually have 2 other YouTube channels. You may have seen a long time ago on my main channel here, I used to do a lot of stuff with fish and shrimp. I have a channel specifically for that called Profiles Aquatica. That's just all the fish stuff goes on there. And then I do a lot of stuff with cars. I've gone racing in my car a few times now. That's on Full Bore. My other YouTube channel, you can find links to the channels on my main channel page. And if you want to follow me there, if you're interested in that sort of stuff, we'd love to have you. Until then, that'll be it for now, guys. Peace out. Have a good one. Stay safe. Happy